Okay, thank you. Good morning, everybody. My name is Mr. Ramsden, and we're going to have a good time. We're going to learn a little bit. Normally I have my telescope set up outside, and we look at the sun and see solar flares and sunspots. But today is raining, so we're not going to do that. Has anybody seen my program before at their school? I can't believe that. Okay, good. What I do, these three holes right here are not part of my program. Just to let you know. What I do is I'm an air traffic controller, and I've been one for 24 years. And I work with Angie and all these folks here, these good people. And we are members of the Black Coalition, and we like to get other people interested in our career, because it's a good career. And we want you to learn about aviation this week, and hopefully get you sparked and interested in the same thing, because it's a good job, it's a good career, and it's on the cutting edge of technology. Now, some of us are a little bit more on the cutting edge than others, but what I do is I talk about solar radiation, and I talk about how it affects aviation technology and aerospace. Has anybody in here ever seen the sun through a telescope? You have? You have? What'd you see? You remember what you saw? Like, did you see any spots or anything? Was it red or white? You remember? Do you remember what you saw? Not really? It was just cool. You remember that, right? Yeah. Yes, sir? Yeah, I can't hear you. Blinding light? Yeah, you probably looked through it without a filter. That's not good. But there's nothing. Oh, by the way, we want everybody here to have a great time, and we want you to get involved in aviation, because we love our jobs, we love each other, and we're a good community group. And we want you to come with us and be part of it. I'm sponsored by National Air Traffic Controllers Association and the National Black Coalition. Two very good groups take care of their people, and they get other people interested in the job and bring them in from the community. There's nothing on Earth or in our solar system more important to the future of aviation and energy and your life than the sun. Okay, the sun's been neglected for many years because people just figured it's always been that way, it's always going to be that way. It's not really that the case, because the higher we go. Oh, by the way, this is a shot you've been watching of Atlanta Air Traffic Control Tower. I had myself up there on the rails on the very top, strapped to the rails because the winds were 50 miles an hour, and I was filming this time lapse, and this is just a sunrise over Atlanta Airport. These two groups sponsor my program, and I go see about 50,000 kids, young adults per year, and teach them about the sun. And the sun, as we go higher and higher in aviation, as planes start flying higher, we got a bunch of them already going over 40,000 feet. And when you get to 40,000 feet and above, it's a whole different story, because did you know that airline employees and passengers and air crews are the most exposed to radiation people in the country as far as jobs go? You are more exposed to radiation above 40,000 feet than any other occupation in the world. Okay, so you'll be a radiation worker, and the radiation comes from the sun. Our troposphere is about 50,000 feet high. You know what the troposphere is? It's the lowest part of the atmosphere where we live, and it's full of water vapor and oxygen, and that's what keeps us alive. And when you get to the top of the troposphere, all of a sudden oxygen goes away, all the protective water vapor and everything goes away, and you start getting exposed directly to sunlight. And like if you was flying over the Arctic Circle and you were going back and forth to Russia, maybe you did that twice a week for a month, you'd have about 400 times the dose of an x-ray at the dentist's office. Okay, so it's a dangerous thing. But anybody seen that movie 2012? How about, what's some other movie where everything's going to blow up? Huh? That, and there was another one, Knowing. Anybody seen Knowing? All that's garbage, by the way. Just to let y'all know, none of that's true. The Earth is not going to explode from solar radiation or solar flares. But we are in a period called solar maximum right now. It's going to last through the end of 2013. And the sun is ejecting large flares and prominences and X-ray radiation all the time. And that's what I look at through my telescopes, and that's what I try to explain to people. We're going to talk about how that works today. But those things are very important to the future of aviation. We have a branch in the FAA called Commercial Space Transportation, and it's still kind of getting going right now. But their job is going to be to regulate space transportation and safety involved in space transportation and all that kind of stuff. And that's going to be the future. So hopefully half of y'all are going to be living on Mars when you get about as old as I am. and everything, you know, you'll have to know a lot about the sun then, because the sun is the major player in the solar system. We live in the sun's atmosphere. You know, we're so close to it. Everything about the sun affects your daily life. So we'll move on. The sun was formed by a large cloud of nebulous gas. And if you've ever seen a nebula through a telescope, it's just a cloud of hydrogen mostly, and there's other organic compounds in it like carbon and oxygen and nitrogen. These things float around the universe and all throughout our galaxy. In fact, every part of you, every atom in your body, every atom in this table, in Miss Angie's hat, all came from one of these nebulous clouds. It existed long before the sun was formed. And what happens is gravity causes this cloud to compress. As you can see, you get a little bit of a core started, and the core is spinning. And as the rest of the cloud compresses into that core, it gets warmer and warmer. Yeah, turn that off for me. Thank you. The cloud gets warmer and warmer towards the center until finally it gets to be about 26 million degrees Celsius, which is extremely hot. And at that point, it erupts into a star. Okay? And the rest of the stuff around the star, all this matter out in here, turns into planets and coalesces into small moons and planets and us. And that's where we came from. Okay? Every one of us is made out of exactly the same elements, and they were all in this cloud before everything started. So that's what it looked like in the beginning. I'm going to go through this kind of fast because we got an hour, and this is a 2-hour lecture, but we're going to talk about it fast. We've been stable for about 4 billion years now, okay? And we're probably going to be pretty stable for about 4 billion more years. But when I say stable, I mean the Earth has not incinerated yet. But there's been many times where flares and things have come to the planet and have vaporized portions of the atmosphere or have interfered with technology. And you probably aren't aware of this, but when we were all growing up, we didn't have cell phones and computers and things like that. All this technology has been developed in the last 40 years, basically, all this micro technology that you carry around. And during that time, the sun has been really, really low activity. So there hasn't been a lot of thought put into what's going to happen when a big flare comes off. In 1869, there was a flare so large that it caught telegraph wires on fire all across the United States and Europe. And back then, that was the highest technology they had, was telegraph wires. The wires absorbed the flare energy, and they just burst into flames. Okay, if that kind of a flare were to happen today, who sends text messages here? Anybody text message? Anybody play video games on the internet? Who got a Facebook account? All that stuff would go away. Okay, because there's one thing in common with all this: ATM cards, telephones, everything. They're controlled by satellites. And if a flare that size came up, all that internet stuff would be gone for several months, and we would lose electricity as well for several months. So if you want to think about going back to the Stone Age, just imagine if you had to get up and you had no electricity and no internet for 6 weeks. I mean, you people, we couldn't last for 2 hours without it, to be honest with you. But there is a special thing to do. Instead of typing the text message, if it all does go out, here's what you do. You put down the phone and you get up and you look at little Jimmy and you say, hello, you use your mouth. Hello, little Jimmy. And then little Jimmy says, hello, little Johnny. That's how we used to communicate before cell phones. But this is the way the sun works. I won't get into much of it, but you see that and that? And these P's right here, these are all hydrogen atoms. And what happens in the sun is 6 hydrogen atoms. Does anybody know what plasma is? What's plasma? It's the 4th state of matter, right? You got solid, liquid, gas, plasma. And plasma is gas that is so hot it's lost its electrons. So when you have a hydrogen atom, that's 1 proton and 1 electron, right? When it gets to be a plasma, it loses its electrons and it just becomes protons. So at the core of the sun is nothing but hydrogen protons. Those protons get shoved together real quick and they briefly turn into deuterium, which immediately evaporates into 2 helium atoms, okay? So what the sun does all day long is takes hydrogen. Let me see your hydrogen atoms. Everybody got 2 hydrogen atoms? Let me see them. Y'all got to wake up because I'm an expensive lecturer. I'm going to give you y'all's money worth. Anyway, throw your hydrogen atoms together and that creates helium. And that's all the sun does 24 hours a day. In that process, it releases energy. And there's an equation this old German dude wrote back in 1904 that describes how much energy is created from a certain amount of mass. Does anybody know what that equation is? E equals mc squared. Everybody heard of that? That equation describes the process in the sun. And what it means is a whole bunch of energy comes from a little tiny bit of mass. 1 hydrogen proton, which there's about 1 trillion of them in my pinky nail, one of those is enough to blow up this entire airport. okay? And the sun releases that energy about